8.2 notes, page number 5. A realtor group has estimated that 19% of all homes purchased last year were purchased as investment properties. Suppose a sample of 100 homes sold last year is randomly selected. Can we assume the sampling for this distribution is normal? So our two criteria are take our value, n, the number in the sample, and compare it to the total number of homes sold. Well, for heaven's sakes. I bet last year the total number of homes sold was huge. So when you divide 100 by huge, it's going to be less than 0.05%. So criteria number 1 passes. Then criteria number 2, we have to test this variance to see if the variance for this binomial distribution is greater than 10. So n, that's the number of homes sold last year sampled, the probability of a success, or p, and the probability of a failure, or 1 minus p. I hope I've done that correct. When you do that, 0.0392, my bad, wrong. When you do that, 15.39. Is 15.39 big enough? Yes. That's kind of disappointing because now we have to do the rest of the problem. So what do we use for the average or the mean? We use 0.19. What do we use for this standard deviation? Well, we have to compute that. So computing that, the probability of a failure all over n. When you plug that into your calculators, go ahead and double check my work to verify that this is correct. But I get a standard deviation of that. Those are the two values we're going to use for this these next 3 cases. Find the probability that the proportion of homes purchased is between 18 and 20%. Cool. Because if they give us the homes, we would have to convert it to a percent anyway. So here's a picture of this event. You can use the appendix 11 and 12 if you want. The average, smack dab in the middle, 0.19. Then we're going to straddle this. 0.18 on one side, 0.2 on the other side, and we want everything in between. We turn our calculators on. Hey, Carol. Clear it, and it's time to enter these values in. Shift data, get over there, and normal CDF. The average this time is 19%. The standard deviation this time is 0.0392. We want the lower bound and the upper bound. So the lower bound, 0.18, and the upper bound is 0.2. Hit it. Hit it. We get 20%. We can convert that to 20.14%. And moving on. Find the probability that the number of homes purchased is more than 25. Okay, so here's the number of homes. We're going to have to convert that to a percentage. Smack dab in the middle is our average, our mu. 25 out of 100. I can do that in my head. That's 0.25. 0.25, it lives over here. You got to compare apples to apples. If they give you the number of homes and we're dealing with probabilities down here, we have to change that to probability. So purchased is more than 25. Boom, 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 boom. Up here, we want to solve this again. Same. Lower bound is 0.25. Upper bound is positive infinity. I think anything bigger than 1 will work here, but just to be on the safe side, I'm going to test that. 6.29%. We're on a roll. With Pearson, you have to be very careful because sometimes if they ask for probability, keep it in probability. If they ask for percent, you got to put it to percent. So be careful on that. We're using Pearson for the test too. I hope that's not a problem. I'm going to solve that again and see if what I just said was correct. When you're dealing with probabilities, the area under those normally distributed curves is just 1. So let's see if the upper bound 1 gives us the same result. By God, it worked. So you don't have to worry about positive infinity because the probabilities can get no bigger than 1. I don't know if that makes sense to you or not. But that is the fact. Here we go. A realtor believes that in her city, there's a larger proportions, bigger than 19%. To investigate this, she just collects 100 again and finds out that of the 100, 33 purchased for investment. Does this sample result support her conjecture? We'll find out here in a second. That would be unusual to expect 33. That is, it would be unusual given the population would be 19 out of that. So I think we'd use the same exact values. But what we want is this 33. I'm sorry, this 33 and above. And 0.19. Everything is the same. The new lower bound, 0.33. And the upper bound, anything bigger than 1 on these when they're probability based. Otherwise, we got to use positive infinity. You can't go wrong using positive infinity for all. And we calculate that. Too small. 0.017%. Since that's less than 5%, this is unusual. Okay, so it supports what she thinks. That 33% is too much. Too much. I wonder where the city is located that you're buying property for business, investment properties, maybe a coastal city, or maybe some kind of a suburb and you're buying apartment complexes. Anyway, that concludes the notes for 8.2. Good luck, everybody. We have a test a week from Tuesday, a week from today. So I guess the test is on the 14th of April. Talk to you soon. Bye-bye.